Good morning, everyone. My name is Johnson Wong, and I am studying here at the University of Nevada, Reno in the Department of Mechanical Engineering. And I would like to tell you a little bit about what I am doing for research. I am working on developing this idea called Lab on a Chip, which is providing laboratory capabilities in a device that can fit in your hand, in the palm of your hand on the millimeter scale. So imagine a device that an EMT can use to quickly diagnose a patient at the site of the incident, to check for infection, to check for blood composition, to check for abnormalities in the blood, right there at the scene of the incident in a small device that can be easily thrown away afterwards. Imagine a device a civil engineer can use to check the water quality at some remote village somewhere in the Sudan. A small device where they can take a drop of water and test for various conditions in this water or various chemicals in the water. Or imagine a device that a biologist or a mechanical engineer can use to test various growth conditions that algae can grow under to develop lipids for biofuels. And that's exactly what I am doing. I'm developing a device, a two-in-one device that can both grow and test the lipid content of algae on a microchip device that can be used effectively and made cheaply. And we can make a lot of these devices to run many tests at the same time. There are a few problems that need to be overcome from this device to come to fruition. For instance, most of these devices are typically made out of a polymer called PDMS and usually on a glass slide. It is well established that PDMS can bond irreversibly to glass slides, but unfortunately my glass slides have gold and chrome on them to create electrodes. So PDMS does not bond very well to this gold or chrome. So I'm developing that for my lab here. An interesting technology that my chip will use is called dielectrophoresis, and that's what the gold electrodes are for. They will create a changing magnetic field which can be used to capture and hold the algae cells. So when I wash the algae cells with, say, different kinds of media with different ions in it or minerals, I can keep the algae on the chip and keep them from washing out of the chip until I want them to. And then the test platform for that I will integrate in this chip is utilizing this technology called fluorescent microscopy. And that basically involves dyeing the algae cells with certain dye and testing the light intensity or the brightness when a light is shined upon these cells. And from that intensity, we can judge how many lipids have grown on the cells, or how much fat and oil overall is in the sample. But unfortunately, the problem with this technology is the fluorescent dye used is easily absorbed into the PDMS chip. So when that happens, the chip can create its own kind of background interference or, I guess, visual noise. And this can throw off your readings significantly. So I have to develop a process to reduce this dye absorption into the PDMS. The overall goal of this device is to have this two-in-one chip that we can make cheaply and basically crowdsource in this Reno Tahoe area. That's basically the idea my grant is built upon, is eventually to have this device and we could send it off to Reno area high school science classrooms, and then we can get thousands of students to run my experiment or run different experiments for me for testing various conditions under which algae can grow. And maybe we can figure out optimal growth conditions for algae to grow under to grow lipids. Okay, so thank you very much for your time. Yes?
So your chip it's not like the universal one. You have to build it for specific use.
Yeah, so it won't be a chip that can do everything, because that'd be very cool, but no, it won't do everything. And there is a lot of development in different aspects of it, like, oh, there's on-chip fluorescent microscopy, there's ways to grow cells on a chip, but it's a lot harder to get everything together onto one chip. So that's the problem, the main problem. Any other questions? Yes?
Sounds like you cross a lot of different fields between biology, chemistry, electrical engineering.
Yes.
Mechanical engineering.
Well, a lot of it is the fabrication. So the MEMS technology is, we have some stuff. I'm developing a lot of it, but most of these things are pretty, they're somewhat established. Like my lab mate's working on the dielectrophoresis. It's established procedures to do on-chip fluorescent microscopy. So there is a lot of cross fields, but there isn't so much of new research for me. It's just a lot of integration.
Are you collaborating with Dr. Kramer's lab?
No, well, he grows algae, right?
Yeah.
There has been some, but it's just really, I'm sure there will be, but I don't think so. We have our own algae samples in our lab. And then, but there definitely is. I have consulted my civil engineering buddy about some questions like, how do you grow algae? And so, yeah, there's a lot of that. Okay, any other questions? Okay, thank you.